All right, so final exam review, day number 2. It is a working together problem, so you do need to know a formula for this one. It says, working together, Dan and Steve can pick up 20 bushels of apples in 5 hours. It's kind of like saying bunches, okay? So it takes them 5 hours to do it together. Had he done it alone, it would have taken Steve 9 hours. How long does it take, or would it take Dan to do it? Okay, so how long would it take Dan to do it? So there's a formula for this, and it looks like this. The total time is equal to the product of their times divided by the sum of their times. Okay, so they gave us the total time. They said together they're going to work for 5 hours. So that's going to be 5 equals 2. And then they said that Steve is going to work for 9 hours. How long does it take Dan to do it, right? So I don't know one of the two variables, so we'll just let Dan be y. We'll let Steve be x. So 9y over 9 plus y. Okay, so at this point, you're just going to multiply things around. You're going to get this 9 plus y, and you're going to multiply it over. Okay, so it's going to look like this. 5 times 9 plus y is equal to 9y. Let's go over here. Now distribute your bottom left, or distribute the multiplication. 5 times 9 plus y. It's going to be 45 plus 5y equals to 9y. Now combine your y terms. So let's subtract 5y on both sides. So minus 5y. That gives you 45 is equal to 4y. Your last step is going to be to divide by 4. Okay, so when you divide by 4, you are going to want to use a calculator here. So 45 divided by 4 comes out to 11.25. So 11.25 hours. That's how long it's going to take for Dan to do it. Now this is usually the harder way of doing this problem, where they give you the total time. The easier way is when they give you both times, and then you just have to kind of multiply and add and then divide. It's a lot easier that way, but this is usually the harder one when they tell you total time was this, solve for one of them. Okay, so the next problem we're going to do is the easier one. Okay, but you still have a lot to write, so I will pause it really quick for you guys to be able to write it down. So let me move it up really quick, and I'll pause it. All right, so for number 13, May can sweep a warehouse in 8 hours. Mark can do the same in 6 hours. How long would it take them to do the work together? Okay, so we're still going to use the formula. T is equal to xy over x plus y. But this time we're solving for t. We can let May be the x value. We can let Mark be the y value, sorry. So x will be 8 and y will be 6. So let me write that down. 8 times 6, 8 plus 6. Let's 8 times 6 is 48. 8 plus 6 is 14. So 48 divided by 14 comes out to 3.43 if we round it to the nearest hundredth. So because it actually comes out to this 4, 2, 8, 5, 7, 1, etc. Okay, so just to round it, let's say to the nearest hundredth, that'd be 3.43 hours. That's how long it's going to take both of them to do it. Usually they're going to make you round if it's going to be an answer either to the nearest hundredth or to the nearest tenths. So in other words, one number after the decimal or two numbers after the decimal, right? Nearest tenths, nearest hundredths. So Yeah, these problems, you just need a formula. And then once you have the formula, you should be able to do the work pretty easy, I hope. All right, number 14 says solve by factoring. Now, we did some of these yesterday, so hopefully you still remember that anytime it says that you have to solve by factoring, you have to set it equal to 0. So we are going to subtract by 6. So we get x squared minus 5x minus 4 equals to 0. Now start factoring. So let's do the x method here. A is 1, B is negative 5, C is negative 4. Did I? Oh yeah, it should. Sorry. Thank you. That would be a positive. Thank you. So C would be a positive 4. And that would have made a big difference. So remember, on the top, it should be A times C. So that's going to be a 4. And then B is a negative 5. So the two numbers that multiply to 4 that add up to negative 5 would be a negative 1 and a negative 4. But notice I don't have to divide this out because A is equal to 1. Okay, so I'm good with that. So let me go ahead and write out my factors. So x minus 1, x minus 4 equals to 0. And now you get to solve for each one independently. So x minus 1 equals 0, x minus 4 equals 0. For the one on the left, you add 1, so you get x equal to 1. And for the one on the right, you'll just add 4 to both sides, so you get x equal to 4. So there's that one. Again, we did this yesterday, so hopefully this is more of a review. The one difference from this one and yesterday's is that yesterday we tended to have an A term, like a 2, a 4, a 6. So we were dividing, right, when we were doing our factoring. Here we don't have to because A is 1. So I didn't have to divide my answers. Are we okay with that one? Did I? Oh no, I didn't misnumber. Never mind. I thought I numbered them wrong. All right, number 15. Solve by factoring. We got p squared equal to 5p. So again, if we're going to be solving by factoring, we have to set this equal to 0. So I'm going to move the 5p over. So p squared minus 5p equals to 0. Now, since it's only two terms, I do have to factor out whatever they have in common. So I'm going to take a p out. And this will be p minus 5 equal to 0. So now that I have my product, okay, I'm gonna separate them into two small problems here. So p equals 0, p minus 5 equals 0. Well, the p equals 0 is already done. The p minus 5 equals 0. I just add 5 to both sides. So I get p equals to 5. So not as hard as the previous one. All right, now these might be a little tough. I don't know how well you guys remember doing these, but if you remember, then it's going to be easier. But if you don't, these are a little bit tougher. So you're going to look at your denominators, okay? Notice how they're all different. I need to make all the denominators kind of disappear, okay? The way I do that is I find the least common denominator, their least common factor, I guess you could say. So what I used to do when I taught this to you guys, I said write down all your denominators. Okay? And what we have to do is write down everything they have, even if it's not in common, but we don't want to repeat stuff. So I don't want to say like one has a 3, another one has a 3, so it's going to be 2 3s. Like, no. 2 out of the 3 terms have 3s. Okay? So 2 out of those 3 have 3s in it. So I'm going to write 3. Okay? All 3 have x's, but you want to write down the x's to its highest power. So square. That's going to be the number that I'm going to multiply everything by. Okay? Or the term, I guess you could say. I'm going to multiply everything by 3x squared. So remember, the way you do that is you're going to start with your numbers first, and you're going to say, what numbers do they have? Well, 2 out of 3 of them have a 3, so I'm going to use the 3. They don't all have to have a 3, but as long as one of them has a number, you're going to want to write down that number. And then you write down the letters to the highest powers that you see. Okay? I'm going to multiply everything by 3x squared. Okay? And this usually, the way I do it, it takes me a little while to write it out, so just bear with me here. But it's just to show you what's happening. So here you go. In other words, I'm multiplying every single term by 3x squared. Now, what you should notice is, let's say on the first one, the very left side, 3x squared times 1 over 3x squared, all of this cancels out. All that's left is a 1. Okay? What cancels out in the middle terms? The x squareds. So it's just 3 times 1 that's left. Plus, what cancels out on the last term? A 3. And how many x's? Just one of them. Okay, so this is going to go away. So that's going to be x times 1. Now let me simplify that. That's 1 equals to 3 plus x. And to solve for x, I'm just going to subtract 3 on both sides. So negative 2 is equal to x. And that's your answer. You only have 2 of these types of problems. Okay, and they're kind of back to back. Well, I don't know if you'll see them back to back, but numerically they're back to back. Any questions on this one? So the next one's going to be similar, but it's going to look a little tougher. So the first thing you're going to want to do with this one is factor it. Okay? Factor the bottoms. That way you can see them a little bit easier. So I'm going to do that for you here. 1 over k squared plus 6k. If I factor out a k, it looks like this. Okay, and then plus 1 over k plus 6 equals to 3 over k times k plus 6. And once you do that, now you do that little thing I did on the right side where you're supposed to check to see what they have in common, right? So let me write this down. All 3 denominators, okay? So it's going to be k times k plus 6, and k times, k plus 6. Those are all 3 denominators. So notice 2 out of the 3 have a letter k by itself, so I'm going to write that down. And then I'm going to look at the solo variable, the k, and ask myself, what's the highest power it has? Well, 1. So that's just going to be a k. Then I notice they all have a k plus 6 in common. And the highest power I see on that, and what I mean by that is, like, if this one had a 2 like that, like a power of 2, then I'd write k plus 6 squared. But since it doesn't, I'm just going to leave it like that. Highest power is a 1 on the outside of the parenthesis. So I'm going to multiply everything by k times k plus 6. Okay? So I think these are like the longest problems that we do in today's review. So let me write this out here. K times k plus 6. Again, forgive me, this is going to take a little while, but I think it's just easier to see it than to try to like imagine it sometimes. Once you start to get better at it, you don't need to do this, but if you don't practice it a lot, sometimes it's helpful. All right, what can I cancel out on the first portion on the very far left? Yeah, everything, right? So all that's left is a 1 plus. What about on the next term? That k plus 6. So that's gone. So that's just k times 1 equal to, what about the last one? Everything here. So that's gone. This is a 3. This is 1 plus k equal to 3. I'm going to kind of work sideways here because I'm running out of room. If I subtract 1 on both sides, I get k is equal to 2. And there you go. I honestly think these are some of the hardest questions you guys are going to see on your final. And they're not terrible, but they're tough. Okay? They are on the tougher side. Give me a second here. There we go. All right, any questions on this one? All right, we're trying to get to 22. We got 5 more to go. So I know it seems like it's taking forever, but it's only been 17 minutes. So my apologies if it does seem like it's taking forever. This is a fraction divided by a fraction. Okay, so what you're going to want to do is rewrite it. This fraction divided by this fraction. All right. Now, we don't divide fractions. We multiply by reciprocals. So let me rewrite this. X minus 2 over 3x times x minus 2 over 4. If I combine this stuff together by multiplication, this is x minus 2 squared, because there's 2 of them. And the bottom will be 12x. And that'll be it. Or maybe they'll write x minus 2 times x minus 2 over 12x. Or maybe they work it out. I'm not sure how the answer is going to look, but that's essentially all you have to do. So it looks scary, but it's not terrible. Just remember, fractions, we don't divide them, we multiply by reciprocals. So you're going to have to flip them around. Are we okay with number 18? Number 19. Now this one you might say, wait a minute, you said we got rid of those hard ones. These are easy. Why are these easy? What, if you look at them, what makes them easy? Why would I say this should be no problem? The what? I can cancel, the tops and the end values. Well, I can't cancel them this way because remember they're supposed to all disappear, the whole piece, right? Here's the reason why I'm telling you these are easy. Whenever fractions have the same denominator, you just add or subtract, right? That's all you got to do. You don't have to do anything special. You don't have to fix it. So all I have to do here is write this. N minus 1 minus n plus 3 over 2n minus 3. And then I just got to fix the top, and then I'm done. Okay? So the top is n minus 1 minus n minus 3 over 2n minus 3. I know n minus n becomes a 0, so that basically goes away. And negative 1 minus 3 is a negative 4. So your answer would be a negative 4. So negative 4 over 2n minus 3. What was mentioned earlier is a good thing. Remember, guys, do not cancel vertically if you see them matching, like we did right here. Remember that it looks like you can do that because they have the same letter, but they have to be matching pieces. So the whole n minus 1 has to cancel out, right? Or the whole 2n minus 3 has to cancel out. Not just the 2, not just the 3, not just an n. Everything in it has to go away. So like right here, I wouldn't want you to do this. That would not be correct. Even though you see a 3 and an n, and you're like, oh, I can get rid of that. That's not right. You have to get rid of all of n plus 3 with another n plus 3. Okay? They have to match exactly. Okay? And I don't know why that's popping up again. I'm guessing I'm clicking on something. Yeah, here we go. Are we okay with that one? Just same denominator, okay? 20 is the same thing. Same denominator, so you don't have to do anything special. So 3x plus 2 divided by 2x squared plus x plus 5x divided by 2x squared plus x. Now, since these have the same denominator, then I can just add these together. So 3x plus 2 plus 5x over 2x squared plus x. I know 3x plus 5x is 8x, so this will be 8x plus 2 over 2x squared plus x, and that'll be your answer. All right, two more. I know that they're not big fraction type problems. So this one says that they want us to simplify this, okay? Anytime they want you to simplify anything, that means there could be factoring involved. And there is in this case. Okay? So let me first rewrite this. I know I can factor stuff out right now, but let me just rewrite. But times p plus 2 over p squared plus 6p plus 5. All right. The 2p plus 10, I can factor out a 2. So this becomes 2 times p plus 5 over 2. On the right side, the p plus 2, I can't do anything with that. But I can factor out the p squared plus 6p plus 5. That's using x method here, where a is 1, b is 6, c is 5. So 1 times 5 is 5. My b value is 6. So I'm going to use a positive 1 and a positive 5. So this will factor into p plus 1, p plus 5. So now the thing is, what can I cancel? What can I get rid of? The p plus 5. There's one more thing I can get rid of. The what? The 2. So what's this basically becoming since everything got canceled out? Not a 0. A 1, right? Anytime everything goes away, this basically becomes a 1. So it's 1 times whatever I have left. So let me just kind of put an arrow here. This is your answer. There's your solution for number 21. Any questions on that one? We got one more. This one's a little easier. It's already pre-factored for you. So we're just going to simplify that. So 2x over x minus 1 times x plus 2 times 3 times x minus 1 over 2x. So what can I factor for this one? The 2x, okay, 2x is gone. What? X minus 1, all right. On top here, there's a 1, okay, since everything got canceled out, there's a 1 left over, just like down here, there's a 1 right here, okay, because it's all gone, so it just doesn't become 0, because or else that's going to cause issues. So here's what it looks like. Right now that we canceled everything out, it's 1 over x plus 2 times 3 over 1. So just multiply them straight across. 1 times 3 is 3. And on the bottom, you're going to get x plus 2. And that's your solution. And that'll be the review.